Welcome. In this video, I'm going to go over the paper 1 or multiple choice questions that were on your chapter 7 quiz over equilibrium. And on the multiple choice, again, focusing on how you can quickly determine if an answer is possibly correct or definitely incorrect and narrow down your choices. So A says the rate of the forward reaction equals the rate of the reverse reaction, and we're looking for statements that are always correct for a chemical reaction at equilibrium. Well, that's true. That is the one definition of equilibrium. Forward and reverse reaction rates are equal. B, the amounts of reactants and products are equal. That can be true, but it certainly doesn't have to be true and often isn't true. So always would definitely not fit for B. C, the concentration of reactants and products are constantly changing. No, the definition of equilibrium is that they're constant. And D, the forward reaction occurs to a greater extent than the reverse reaction. That is also not true, as the reaction rates are equal in both directions. So A is the only true statement. Number 2 is a little bit tricky. It says which statement is correct for a crystal of iron sulfate in a state of equilibrium with a saturated solution of iron 2 sulfate. So you got a chunk of the solid in a saturated solution of the same stuff. So that means that some of the sulfate crystal may end up in solution, but at the same time, an iron ion and a sulfate ion would reform a crystal or solid ion. So the color of the solution darkens as the crystals continue to dissolve. No, that's one of those macroscopic properties that will not change. The color is going to remain constant. The concentration of the iron sulfate solution increases as the water evaporates. That seems like a plausible thing until you look at the picture and you see there's a stopper there. Part of equilibrium is nothing can enter or leave, so you're not going to allow evaporation to occur. C, the shape of the iron sulfate crystal does not change. That's not true. The size of the sulfate crystal is going to remain the same, but if an iron sulfate crystal ends up breaking apart and becoming iron and sulfate ion at the same time as an iron and sulfate ion combine to form the crystal, they may not replace each other at the same place. So a crystal, the iron and sulfate ion may leave one area of the crystal and a deposit may take part on another. So the shape may change, but it's going to be pretty microscopic. I'm not sure you're going to notice it, but over time, I guess you could. And D, the color of the solution does not change, but the shape of the crystal may change. So the color's not going to change because the net in and out of crystal to solution is going to be the same, but the shape of the crystal possibly could change. So D is the best choice there. Number 3, for the following reaction, we've got a Kc value of 1 times 10 to the minus 5th. So it's definitely less than 1, so we know there's more reactant than product. And the other thing that IB expects you to know is when you get to a magnitude above 1,000 or below 1/1000th or 10 to the minus 3, then it's considered that the equilibrium lies far to the right or far to the left, really favors reactant or really favors product. So A, the concentration of NO equals the concentration of NOCl. No, the equilibrium constant isn't 1, so we know the products and reactants aren't equal. B, the concentration of NOCl is double the concentration of Cl2. Again, no, that doesn't need to be true. We know that there's more NOCl, but double is unlikely. That would probably give us a Kc around a half. Plus, the 2-to-1 ratio is true for the molar ratio, but that is not true at equilibrium at all. So don't mix those up. Molar ratios and equilibrium concentrations are not the same thing. See, the concentration of NOCl is much greater than the concentration of Cl2. That is true because of the small exponent there, the 10 to the minus 5th. We know that the equilibrium lies far to the left or far to the reactant side. And D, the concentration of NO is much greater than NOCl. No, we know that the concentration of reactants is much greater. So C is my best choice. Number 4, what is the effect of an increase of temperature on the yield and the equilibrium constant for the following reaction? Now remember, temperature is the one stress that will change the equilibrium constant along with the equilibrium position or the yield. So temperature, I see it's an exothermic reaction, so I can think of heat as being a product, or heat increases collisions more on the product side than the reactant side. So that means an increase in temperature is going to push the equilibrium to the left and decrease my amount of product, which decreases my yield. And when my yield decreases, that means my Kc value also decreases. So D would be the correct choice. And I made D worth 2 marks. And if you had either B or C, so you knew one of the effects correctly, I gave you 1 mark on this. Number 5, I did a similar thing. I gave 2 marks for the correct answer. If you had one of the conditions right, I gave you 1 mark. So number 5, you've got an equilibrium equation there with methanol and methanol vapor. So what you're supposed to realize is to go from a liquid to a gas requires energy. That's an endothermic process. So what happens to the position of equilibrium and the value of Kc as temperature decreases? Well, if temperature decreases, that's like removing a reactant. So the equilibrium will again shift left and cause a decrease in Kc. And Kc is only changing because this is a temperature change. Number 6, the reaction below represents the Haber process for the industrial production of ammonia. The optimum conditions of temperature and pressure are chosen as a compromise between those that favor a high yield and those that favor a fast rate of production. Economic considerations or cost are also important. Which statement is correct? A higher temperature would ensure higher yield and a faster rate. Well, the faster rate is true, but higher yield is not true. Being exothermic, a higher temperature is actually going to ensure a lower yield. B says a lower pressure would ensure a higher yield. This is not true because I've got 4 moles on the reactant side and 2 moles of gas on the product side, so a higher pressure would increase my yield. C, a lower temperature would ensure a higher yield and a faster rate. A lower temperature would give me a higher yield since it's exothermic, but it would give me a slower rate. D, at higher pressure would ensure a higher yield at a higher cost. That one is true. A higher pressure is going to push the equilibrium to the right, increase my yield, but it will cost more. Number 7, consider the endothermic reaction below. Which change would result in an increase in the amount of CO2? So since it's endothermic, heat is a reactant, or heat helps the reactant side increase its collisions more. So increasing the temperature will increase CO2, since CO2 is a product. Decreasing temperature will move the equilibrium to the left and decrease my CO2. Increasing or decreasing pressure, when I look, I see I have 6 moles of gas on the reactant side and 6 moles on the product side. So changing pressure is going to have no effect on this equilibrium. So A, only increasing temperature can increase your yield. And number 8, consider the following reversible reaction. What will happen to the position of equilibrium and the equilibrium constant when more hydrogen ions are added? So hydrogen ions, are a product. So when you add a product, you shift the equilibrium to the left. And when you shift the equilibrium to the left by adding a reactant or a product, that has no effect on your equilibrium value. Only temperature will change that equilibrium constant. So D would be the correct one. It shifts left but does not change the equilibrium constant. And again, I made that worth 2 marks and gave you 1 mark if you knew the effect of one of those two. And that's the paper 1 questions from our chapter 7 quiz.